Hey everyone, welcome back to our data science course. Today we're diving deeper into Pandas and NumPy, two of the most powerful libraries for data analysis in Python. By the end of this video, you'll be able to manipulate data like a pro, using Pandas to clean and modify datasets, handling missing values, and performing powerful NumPy operations. If you're serious about learning data science, make sure to stick around. Let's get started. First, let's create a NumPy matrix. We start by importing NumPy as NP. We create a matrix which is filled with random numbers, which is made possible by NumPy. We create it by np.random.randint, maybe numbers between 1 and 100, and let's create a matrix of 4x4 format, like this. Now let's print it out on the screen. This is how easy you can create your first matrix using Python's NumPy library. But as you can see, we can generate every time new results. Maybe we want to stick around into the same numbers that will be generated. How we can do that? By doing np.random.seed42. So we might use this so we have consistency into experiments with the same numbers. Now as you can see, 52, 93, 15, 72, every time is the same results. NumPy is a powerful library which provides powerful functions for numerical computations. NumPy provides powerful functions for numerical computations. Let's break them down one by one. First, we can calculate the mean of matrix by just using the... Now let's create a better structure for printing our results. Print of matrix, comma, np.mean, and then we have matrix, and then we just print it out. Oh, it didn't close. Okay. The mean of matrix is 51.625. And then we can create the we can provide the sum of columns. So we will have generated columns that have the sum of every single column. So in our case 52, 61, 65 and 3 will be as one value in the first column, or 0, 93, 21, 75 and 22 will be as one value, the sum of all rows of that column. And then we will generate the sum of rows. First we will print out the sum of columns. Okay, let's write columns. We do this by just using NumPy sum matrix x is 0. This is for columns. Print out the same error. The sum of columns, as you can see, 191, 211, 239 and 185. Now we print out the sum of rows. We're using the same logic, just now instead of x is 0 we put out x is 1. And as you can see, 4 results for our rows. As we have 4 rows, it has 4 results. And maybe we can find the standard deviations of a matrix by just using a simple function made possible by NumPy. Just by using comma NumPy dot std, which stands for standard deviation of the matrix. With just a few lines of code, as you can see, we can analyze complex datasets and extract useful insights. Now that we have our NumPy matrix, let's convert it into a Pandas data frame. This step is important because Pandas allows us to work with data in a structured format, just like an Excel sheet or a SQL table. Each column gets a name, for example A, B, C, D, which makes it easier to manipulate. Now we import pandas as pd. df is our variable for data frame, pd.dataframe. Matrix that we generated. Let's add columns, a list of columns, for example A, B, C, and D, because we have a 4x4 matrix. Let's print out our data frame. Let's name it initial data frame, as we just print out the matrix into a data frame in a Excel format like Excel sheet. And let's use \n and comma df. Oh, it didn't close. Okay. Now, as you can see, we have the initial data frame. We used this \n to create a new row, to go into a new row, and then we have A, B, C, D, our columns that we generated to look like in an Excel sheet. We have 0, 1, 2, 3 number of rows, and this is how it's better structures a matrix that we have from NumPy, and now we have it like visualized, or we have it in a structured format just like an Excel sheet, or maybe as in a SQL table. Now let's add a new column named total. Now df is our data frame. Let's add it as total. This is a new column which equals data frame dot sum. X is 1. So as we told here, x is 1 is used sum of rows. So we have the sum of rows into a new column which is named total. Let's print out now our data frame. Now new row. Let's go into a new row, data frame with total column added, \n, close df, and let's test it out. Now as you can see, we have the same results as we had in NumPy, but now we have a structured format with the total column added and with a format like a SQL table or an Excel sheet. Now let's test dropping a column, and we will have a new question. We will have a question that we see in most of the times. We have the inplace true or without inplace true. What does it mean? It means without the inplace true, that is a variable, modify the data frame, but we don't change the original. So we create a new data frame with all columns that we have, just without the total, for example. But it's not this data frame, it's a new generated data frame, so it doesn't change the actual original data frame. If we use the inplace through, then we will edit the existing data frame. Let's test it out. df copy, and we have df.drop columns dot equals total, and let's print it out for now. Data frame after dropping it's capital total without inplace true. This is the data frame that we have without using the inplace true, and using a comma and df copy, as it's our new data frame. So as you can see, we did not close. Okay. It's not structured good. So the new data frame has been created. As you can see, it's a df copy. It's the copy of this data frame, but without the total column. Now what to do to change the actual original data frame? We simply copy this line. Now it's, instead of df copy, we do not need to generate a new data frame. We just update the existing data frame by simply using inplace true. Now let's print the data frame. Let's move into a new row. Data frame after dropping total with inplace true. Now let's test it out. Go into a new row because it will be structured in a better way, and we use df, and let's just print out on the screen. As you can see, is the df data frame. It's the same as here that we added total column. Now it's the same that is being changed into the original data frame without having the need to move into a new data frame and storing without need. It is necessary if we want to have those data but without this column. So it depends what we need, then we use the inplace equals true. Now let's move into a new step. Let's handle missing values with inplace equals true. Why? Because we want to fill the missing values. For example, let's use a new let's use the existing data frame, and let's make a column have a row that has a missing value. How we do that? df lock, it's for example 0 1 2, it's 2 at c equals none. Now what we'll do with this, we will add a missing value. Let's print data frame. Let's do formatting. Go into a new row. Data frame with a missing value, comma, oh, let's do a better structure, df. Let's move into a new row and let's close it. So as you can see, we have a none, no value, into 2, 2. It's 0, 1, 2. C column, we have a missing value. How to handle those missing values? We do this by using the inplace true, as we learned in our previous example. So we update the existing data frame with missing values. With what do we fill it? In our example, we will fill it with a suggested number. For example, we do not use none, not a number, but we use 0 instead of that. In real life datasets, most of the time we use the mean function to generate a mean value, for example, of C column. For example, if we have a forecast of weather forecasting, we use to handle missing values, we use mean of, for example, last 10 days, and we generate the mean of those last 10 days or last 365 days. We generate a value, so we do not have not a number values, but we have real values. So when we visualize plots, it will not have errors or anomalies. In our case, we will simply use df. Fillna is the function to handle missing values. For example, use 0. Inplace equals true. And what does this do? As we didn't specify which column, which row will be filled, it will automatically fill all the missing values. In our case, we have just one missing values. So now we print out the data frame that we have updated. So as you can see, we had the inplace true to fill the data into the original data frame. In this game, data frame after filling missing values is printed out on screen. This one just 0 instead of not a number values. Now let's test it out. As you can see, it's 0.0. Now let's try something different. Let's try and sort the data frame. Sorting is a great way to find top performing products, students, maybe financial threads. And here how we're sorting a specific column. For example, let's use the A column and sort it into a descending order, meaning that the highest values will appear first. For example, in this case 75, 61, 52 and 3. Now let's try and sort our data frame. How we do that? df, we sort a variable, df sorted, df is the data frame, sort values small by, this is by A is the column we want to sort, ascending equals false, so we use the descending sorting. We print out data frame sorted by column A. Go to a new row and comma df sorted. Now that we expect to sort the A column from highest to lowest values. Let's test out. As you can see, the data frame has been sorted, and as you can see, the second row is the highest value for a column. What we did here was we sorted all data frame just by a column A. It's like on the SQL table where we extract data or values from the database, where we, for example, we sort by names. So it doesn't mean they have the ID 1, 2, 3 that it's going to be sorted, but it depends on the column of the table, or in this case of our data frame, that the results will be sorted out. This we use, for example, into products that we'll list out on our application, where we find the most sold items, we find the most top performing students, or if we want to analyze financial trends. Now we can filter data into our data frame. For example, only rows where value is greater than 50. So as you can see, the row third with a value 3 at a column should not be in our list. We don't want to see the low performing products, for example, into our list. We want to see only top performing products, for example, those who have been sold 50 or more into a specific date. We use the df filtered. This is the name that we want to use for our variable df a. So we use again the a column where values are greater than 50. We print out on the screen the filtered data frame only. Let's do this. Only rows with values greater than 50 in column A. Let's move the new row, comma, df filtered, and as we expect, the result will be only 3 rows with the third row missing, as it has values that are lower than 50. Let's quickly recap what we covered today. We learned how to create a NumPy matrix, a random NumPy matrix, convert the arrays into Panda NumPy arrays into Panda data frames, and then modify the data frames dynamically with adding a total column, for example, as we used, with dropping total column and cleaning the missing values. And we also understood why we have the inplace true and why does it matter in data frames. We also understood how to sort and filter the data efficiently, and why we need filtering or sorting in our real life experiments. Now, this was a great job, and in the next lesson we'll cover data visualization using Matplotlib and Seaborn, where you will learn how to make beautiful charts and graphs from data. Thank you.